aerodrome and usually cover a period of between 9 and 24 hours. TAFs are different from the METAR in that they describe the forecast conditions at an aerodrome and usually cover a period of between 9 and 24 hours. 9-hour TAFs are usually issued every 3 hours, and 12 to 24-hour TAFs every 6 hours. The TAF is issued separately from the METARs, but many of the codes and groups in the METAR are also used in the TAF. We shall only consider the main differences in this lesson. Shown here is an example TAF. The first obvious difference is that the reported identifier is now a TAF, not a METAR. The echolocation indicator of the airfield issuing the report is the same as that for the METAR. Again, we use Kidlington. Remember that the METAR was just an indication of the weather at a specific time. However, the TAF aims to give a forecast over a period of time, so the TAF will have a different time group to the METAR. The first of these is the time of origin, the date first and then the time in hours and minutes in Zulu. However, the validity time comes next. Again, this will start with the date, then the start time in hours, and then the end time in hours. So here we have a validity period from the 13th at 0700 Zulu to 1600 Zulu the same day. In other words, a 9-hour TAF. The decoding of the wind is the same as for the METAR, and the example shown here is a mean wind direction of 310 degrees true at 15 knots. Visibility in the TAF follows the same coding rules as the METAR, except that only one minimum visibility value is shown. In our example, the visibility is 8,000 meters. Much like visibility, the weather coding for the TAF is the same as the METAR, and the table shown here is to refresh your memory. However, cloud coding is slightly different than the METAR. If there is no cumulonimbus, or any cloud below 5,000 feet or below the minimum sector altitude forecast, and CAV-OK or SKC does not apply, then the code NSC is used. This stands for No Significant Cloud. Another difference is that only cumulonimbus clouds are ever reported in TAFs, whereas in the METAR, towering cumulus and cumulonimbus clouds were reported. The main TAF information ends at the cloud group. You may recall, though, that the METAR had a lot of extra information after the cloud groups, as shown here. TAFs, however, do not have any temperature and dew point, QNH, recent weather, wind shear or runway state information. Only significant changes of weather follow the cloud group. This part looks at how the significant weather changes are coded within the TAF period. The first change indicator is FM, meaning from. This is followed by a time group in hours and minutes as shown here. This means that from 12:20 Zulu, certain weather changes will occur. These weather changes will supersede the corresponding weather prior to this period. In this example, from 12:20 Zulu till the end of the TAF period, the wind will change to be 270 degrees true at 17 knots with a minimum visibility of 4,000 meters and some broken cloud at 1,000 feet. This is just one type of weather change indicator that can be used. The change cannot be accurately forecast to the hour and minute, then another code is used. The change group becoming, followed by a 4-figure time group, indicates the expected beginning time of a permanent change in the forecast conditions. These may be regular or irregular and starting at an unspecified time within the period given. By the end of the time period given, the change would have occurred and the conditions suggested will now prevail. Let's look at the example. This means that at some time between 0900 Zulu and 1100 Zulu, the visibility will permanently become 5,000 meters in light rain. Notice that the wind information has not changed. It will still be 310 degrees true at 15 knots. The other change indicator is tempo, meaning temporarily. This is different than the becoming change indicator in that this change may occur at any time within a specified time period and not be a permanent change. These temporary fluctuations are expected to last less than an hour each time, but in aggregate no more than half the time period given. Let's look through this example. Between 1200 Zulu and 1400 Zulu, the visibility will fall to 4,000 meters, with the weather being thunderstorms and moderate rain. There will be 5 to 7 octaves of cumulonimbus cloud at 1,000 feet. However, after 1400, the weather will return to the base conditions specified here. A probability indication can be used to assess the likelihood of occurrence and is shown by the code prob. This is expressed as a percentage of either 30%, which is considered low probability, or 40%, which is a high probability. Probability can be followed by a time group, as shown here, or by an indicator, such as becoming or temporarily. One last thing must be covered before we finish the lesson. When a TAF requires an amendment, the amended forecast may be indicated by inserting an AMD after the TAF identifier, as shown here. Hopefully, from this lesson you will now be able to accurately decode the TAF message. Remember, it is a forecast of the expected conditions and therefore essential to your MET briefing prior to your flight. If you use TAFs correctly, you'll be in a better position to make accurate and informed decisions about your flight and the expected conditions of the aerodromes you visit.